Hello! All right, so I'm Julia, and today we're going to talk about one of my favorite things, which is debugging tools. I was thinking a while ago about how I got better at debugging, because I used to find debugging really hard and boring, and now I find it interesting, and also I think I can solve harder bugs. And I wanted to, and I was like, okay, how did I get better at this, right? Like, what happened? So some things that happened include, I think I got, oh wow, this is exciting. Great. Oh, I know how to debug this. Or I have debugged this before. Okay, I think that's it. By which I mean my audience has helped me debug it before. So one thing that helps is remembering that your bug is happening for a logical reason, even if it seems to make more sense. Someone at lunch told me about a bug that was happening because of solar flares, which is very surprising but still logical, right? So even if things have no obvious external cause. Anyway, there's still reasons. Another thing that's helped me is to be more confident that I can fix my bugs. Sometimes I'll spend 3 weeks debugging something, and I'll be like, I really hope I fix this, because if I don't, it'll be kind of embarrassing. And I think these days it's easier for me to be confident, because I'm like, well, I fixed a bunch of hard bugs, so I can probably make it through this one too, even if I have no idea what's happening right now. But the two most important things, I think, have been to know my debugging toolkit and be able to answer the questions that I have about my programs, right? I'm like, okay, is this a problem with this server, or is it a problem with that server? Or is this a problem just in Go, or is it also a program in other programming languages? And I've gotten a lot better at that over time, and I feel like it's made a really big difference to my ability to debug software, and that's what I'm here to talk about today. The other thing that has helped me is I really like debugging now, but I'm not sure I can convince you to like it, although I might try. All right, so the scenario we're going to work on here is that you log into a computer and something has maybe gone terribly wrong, right? So it's exploding, or what's happening to this program right now. Usually for me it is actually more 3 p.m. and 3 a.m. when I'm debugging, which is good. You can be less upset and more excited. So when I started out debugging programs, I would often do things like maybe try to read the code, or I'd print statements, and I thought it was maybe important to know the programming language, and I don't believe in this as much anymore. I found some alternative methods, which I really enjoy, and we're going to talk about some wizard tools. But wizard tools are not really a thing. I just told you that computers aren't magic and we use logic. So by wizardry, I mean asking your operating systems what your programs are doing, right? So instead of being I'm going to use a Python debugger, you're yo, what file is my program opening? And the operating system is it was the wrong file. And you kind of just get the operating system to tell on the program, right? You'd be yo, what's it doing really though? And the operating system will generally tell you the truth, unlike your program, which might lie to you because you wrote it, right? All right, so we're gonna solve 3 mysteries because I like mysteries. And we're going to have the case of the missing configuration file, the case of the slow program, and the case of the French website, because I'm from Quebec, and we do bonjour. And then we might have more time for more cool stuff, we'll see. So we're going to start out with the case of the mystery configuration file. Does this happen to you, where you write a configuration file, and then you start your program, and it's oh, no, didn't work. So I frequently might edit the wrong file. This is partly because I don't always like reading documentation, so I'll just try a file that seems right. But I didn't want to fix this problem necessarily by reading documentation, because why would you do that? I wanted to show you how to figure out the configuration for a program without reading the documentation. So we're going to use the example of bash, right? It's does bash use .bashrc or .bash profile when it starts? And you can figure this out by reading Stack Overflow, the documentation or something, but we're not going to do that. We're going to use strace, which is my favorite program. I have an strace sticker on my phone. So what strace is it traces system calls. So system calls were this really big revelation to me a long time ago. a few years ago when I started learning about operating systems. And what system calls are like kind of the API for your operating system, right? So when every time any program opens a file, it's like, please, can you open this file? And your operating system will be like, yes, here it is. And your program is like, please read these bytes from it. And the operating system is like, yes, here they are. Or sometimes there'll be an error, but hopefully you handle those errors too. Anyway, so strace output is very exciting. It kind of looks like this. At first I used to find this kind of intimidating, but I've gotten better at not finding it so intimidating. Oh wow, this is exciting. Okay, cool. So what we're going to do, what we're going to do is we're going to figure out what configuration file bash uses by stracing it. So we're going to run strace -f-e open -o out. Oops. Okay. And then we're going to find things that mention bash in the name. And we're going to find all the files. Okay, cool. So there are a bunch of files that it opened. It opened .bash history, it opened .bash rc, and it opened some weird files to do with TensorFlow completions. Cool. So I think this is awesome because it's like, it opened .bash rc. And then that's it. I know that it didn't open the bash profile file at all, so it can't have been using that to configure itself. Otherwise it would have opened it. And I didn't need to read the bash source code or documentation at all. So we won. Something to know about strace is it can make your programs run 50 times slower, so you shouldn't run it on your production databases. You shouldn't. But I like it, well, at least for like safe programs. It's good to run on programs which are already broken because you can't really make them that much worse. That's one of my favorite places to run it. But it's a good way to just be like, what is this program even doing, right? Like, what's happening? So you can check to see if it's like reading a file or making network requests or like waiting for a mutex. I had a fun time once where someone was like, Julia, I have a bug in an Erlang program. And I was like, I don't know what Erlang is. But I just like straced it. And I was like, there's a lot of mutex stuff going on. Maybe it's waiting on a lock. And he was like, oh yeah, that's totally it. And I still don't know Erlang. But I was like able to help. Just by running strace, and I felt really proud of myself. You can also check to see if it's writing logs. I wrote a zine about strace, which we'll go into later. But there are also some faster system call tracing tools, which I've been using more recently. My favorite one of these is perftrace, because it's like generally available on Linux. Recently, I had a weird like Docker issue, where Docker PS was taking forever, and I ran perftrace, and I was like, oh, Docker is opening 200,000 files. Cool. I guess that's why like it's kind of slow. And it turns out that if you ask it for the size of to measure the size of your containers, it does that by running stat on all the files, and then adding all those up, which like takes a second. And then there's also dtrust on OS X, and there are some eBPF-based tools like OpenSnoop on Linux. And I'm pretty into these tools. Perftrace like doesn't give you as much information as strace does, but it won't slow down your programs, which is very exciting to me. Okay, we're gonna solve another mystery, which is the case of the slow program. Also the case of the projector. We're gonna try this again. Cool. I think what I'm learning here is I should have screwed in my VGA cable. Okay, cool. Great. Okay, so we're gonna have 3 slow programs. One of them is slow because it's just like spending too much time on the CPU. One of them is slow because it's writing too much to disk, and one of them is slow because it's waiting for a slow server. And we're gonna debug all of them without like reading their code or anything. And it'll be really exciting. So the first one, mystery program number 1, I ran time on it to start. Time is a cool thing because it'll tell you like how much of the time when you ran that program it spent on the CPU. So this one spent 5% of its time on the CPU. And what that means is that the other 95% of the time was spent like waiting for something, right? Because if you're not calculating, you're like chilling and being like, okay. So like, what was it waiting for? Exciting question. So let's find out. We're going to look into the kernel soul, because often when a program is waiting, it's waiting for the operating system to do something. So we'll just be like, okay, what you doing? What's up, Linux? So we're going to run Python mystery1.py. Cool. And -f. Cool. So I found its PID. And we're going to look in /proc, which is this magical directory, which has all kinds of interesting information about the program, like the command line that it, oops. Nope. Anyway, we're going to look at stack. So this is what? Oh, I wrote it twice. Okay, cool. So this is the kernel stack right now for that program. So what is this program doing? Someone whispered, waiting for a network. It's waiting for a network reply, right? And this is kind of cool. We just can like see what this program is doing. And it's a Python program, right? It's not like a fancy systems program, just a regular Python program, but we can see what it's doing. And so I'm like, sounds like networking to me. Now I know what's happening. And so I think it's cool that like you don't need to be a kernel hacker to read a kernel stack trace. You can just look at it and be like, oh yeah, I know what that means. Sweet. So we won. We solved that mystery. It was the network. And this is what the program is secretly doing behind the scenes. It's just like, I'm going to wait forever before returning. Then next up, there's mystery program number 2. And this is a Ruby program. And it's using like 93% CPU. And last time I gave this talk, I just kind of ended this with like, just like use a Ruby profiler. The operating system doesn't have anything to say about this. But this time I was like, no, maybe the operating system has something to say about this. We can actually find out. And we're going to use my other favorite program. I have a number of favorite programs. My second favorite program called perftop. Well, it's called perf, and the top subcommand of perf. So perftop is a fun thing to run. It's kind of like, so top tells you like which programs are taking all the CPU on your computer, and perftop tells you like what C functions are taking all the CPU on your computer. So I like to kind of like run top, and then if something is taking a lot of CPU, I'll just like run perftop and then see what happens, and if it tells me anything useful. And it turns out that with this program, it does. RBN. Okay, so I'm going to run this program a bunch of times, and then we're going to run perftop and see if it tells us anything useful. Okay, so these are the programs. You can see there's some things like libcomposite.so composite window. I don't know what that is. It's like probably related to Chrome somehow. But the thing at the top here is forward search range from Ruby. So like, what could that be, right? So we can like go to our Ruby source code of the Ruby interpreter and see what we find. And we're like, oh, that's somewhere in the regular expression code. So like the reason this is useful is that like it won't tell you like what Ruby function is being run, but it will show you like where it is in the Ruby interpreter, which is normally not useful, but in this case it is useful. And like the other day I like SSH into a machine and it was like using a bajillion CPU and it was in like a regular expression function, and then I could just tell that was happening within 10 seconds, which was useful. So we kind of like know something about what's going on already, and we just had to run one command. Which is exciting to me. So we blame regular expressions. Don't do it. Cool. Mystery program number 3. If you remember the 3 things from the beginning, you can guess what it is by process of elimination. I have bad memory. This one is using 94% CPU. And you might be like, okay, this is the same as before. This is just using a lot of CPU. It's not like interacting with the operating system at all, right? However, you see where it says like user mode and system mode? So it's actually, there's a ton of CPU, but it's all in the kernel. What's up with that? What are you doing, program? Why are you making, what is the kernel calculating, right? So I'm going to start out by telling you about dstat, because I happen to know what this program does, surprise. Okay, so Python mystery 3. And we're going to run dstat, because I love dstat a lot. Whoa. Okay, cool. And then we're going to run our program. So dstat, what it does is it just like prints out everything that's happening, like all the CPU and disk and network activity every second, which is kind of fun to like stare at if you have a computer which is like misbehaving, and then you're like, ah, I see that spike in writes. What was that? I mean, it's kind of like looking at a graph, but I guess on the command line. So if we run our mystery3.py program, you can see that suddenly like a lot of writes appear in the writes column, and it's like, I'm writing 300 megabytes to disk. And then there's a pause, actually, and then it writes a whole bunch more after the program exits, which is like, at first, like it gets written to the file system cache, and the program exits, and it's like, okay, I wrote it, no problem, but it actually hasn't been written to disk yet, and then the operating system writes it later, which is what that gap is about. Anyway, what is going on, right? Like what is all the CPU about? Because writing just normally shouldn't take that much CPU. So we're gonna run this in a loop somehow. Okay, yeah, there's our loop. And then we're gonna run perf-top again, because I love it a lot. And then we start to see some stuff. Really? Why not more of that? Okay, that's fine, I guess. Oh yeah, there we go. Okay, so up here at the top, you see a thing that says AES. What does AES mean? Yay! Encryption. It's writing to my home directory, and my home directory is encrypted. So it takes a lot of CPU, apparently, to write to my home directory. But it takes CPU in the kernel, right? Like it doesn't get encrypted in user space. The program is just like, I would like to write these byte to disk, and the kernel's like, oh my god, I have to encrypt them first, right? So, cool. Great. So perf-top has helped us again. And my attitude towards perf-top is really like, it's really not always useful, but I just like to look at it, and sometimes it helps. And kernel functions are not just for kernel hackers, sometimes they just make sense, which is really nice. Another cool thing about perf is, so far all of the uses of perf we've seen are telling you what C function you're running, but there are actually plugins for both Node.js and for the JVM, because those are both JITted, so like you can get Node to tell the perf system, like, hey, this address actually means this JavaScript function, and then you can get the perf tool to report to you what JavaScript function you're in, or like what like JVM function you're in, which I think is really cool. Okay, we have one last mystery, which is the case of the French website. So let's go solve that one. Okay, so I made a website. It says like, hello Monitorama. And if I get it from the command line instead, there we go. Instead it says, bonjour Monitorama. Comment ça va? Great. So like, why do we get different results, right? Like, why is it in English in Chrome and not in English on our command line? So we're going to find out with ngrep, which is like grep for your network, which is the best thing. And then let's see if I have this ngrep incantation somewhere. Yeah, here we go. Okay, so we're going to start just like looking for GET requests on localhost. And so we're basically just like grep get. So I'm going to run this curl command, and I'll run this chrome command. And then we have these two requests here. So you can see the curl one is first, and it's really short. And the Chrome one is second, and it's kind of like longer, right? So it kind of makes sense. You're like, okay, well, you made two different requests, and you got two different responses. That's reasonable. But then down here, if you kind of look at the headers, you're like, oh, there's an accept language header, where it says accept language ENUS. Cool. Maybe that's related, right? To the language that we got the content in. So because Chrome asked for an English website and curl did not ask for an English website. So we can just like try that. And then it's in English instead of being, instead of being in French, which is exciting to me. Cool. Now we're going to see how much time we have left. Cool. We have like 9 minutes. Great. So we're going to talk a little bit more about we're going to talk a little bit about TCP dump. Because when I started giving this talk, I would talk about ngrep, and I'd be like, ngrep is great, but TCP dump is really scary, and we're not going to talk about that. But now I love TCP dump, kind of, and so we're going to talk about TCP dump. So I had a problem at work recently where someone was like, hey, there are some DNS queries that are like intermittently failing in this weird way. And it was at a pretty slow rate, like maybe like 5 an hour. So it wasn't really an emergency, but also like we wanted to know what was going on, especially because we'd had a DNS issue in the past. So we're like, okay, we should figure this out. And we had a few different like layers of DNS servers, and it wasn't really clear who to blame. And I was confused about this for a while, right? And there are all these questions like, so we're in AWS, so we're like, is it just a problem on AZ, or is this a problem with Go? Because like I think Go uses its own DNS library, and like a lot of the problems we were seeing were with like Go clients, or like is this like a weird ARP table problem that we've had before? And so there are all these different theories, right? That we were trying to work out, and it's kind of I think natural to be like. Or like one thing I used to do is like try to like find the smartest person, the most experienced, and be like, which one is it? But this strategy like does not work, right? For a few reasons. One is that the smartest person is like often not like there. Also, like just because they're really smart doesn't mean that they magically know the answer to your DNS problems. And it's like much better to rely on like facts, right? Instead of like just being like, I magically saw this before, so I know the answer. And so no one knew the answer, as is expected, right? As often happens. So at some point, after kind of like thinking about this, I was like, oh, I know what I'm gonna do. And these errors are really infrequent. So I was like, I'll use TCP dump, which is this tool you can use to save network requests into a file, and then I'll analyze them later, right? Because there are only like maybe like 5 errors per hour, so I couldn't like catch them as they were happening. So I started TCP dump, and we were having these weird DNS failures, which weren't just like an NX domain. It was like the DNS server had just like thrown up. So it was like, I don't even know, man. So I concocted this TCP dump VPF filter where I was like, okay, take everything on port 53, and then this weird thing is just saying like not an NX domain and not a success, and then save those to a file. And then I let that run for like 12 hours. And I was like, okay, if I have this data, I'll know like everything that happened in the whole system, right? Because I just like ran it on a couple of different DNS servers, and I'm like, I'll know everything. So I'll be able to like confirm or deny all my hypotheses, which was really true. And then I woke up in the morning the next day, and I was like, oh boy, I have packets to analyze. This is so exciting. And it was really cool because it let me like immediately see who I could blame. And this is like I think the really wonderful thing about like packet analysis and like networking is you have like the clients and the servers, and you can like really easily be like, you sent the bad request, or you were wrong. And then after I did that, I was able to like pretty quickly see that like we had some like upstream DNS requests to an external server, and that those were timing out. And I was like, oh, that was what went wrong. And then we could fix it. And it was all thanks to the power of TCP dump. And I was really happy. Cool. So maybe, and also shout out to Wireshark, because using TCP dump to like capture packets is pretty great, but often like looking at packets with TCP dump is not great. And Wireshark is like this like graphical tool where you can just kind of like click on things and be like, oh, okay. Like, that's weird. So yeah, guessing the answer magically is hard, which is I think what this conference is all about. Tools can help you answer the questions without having necessarily seen the exact thing before. And you can learn these tools. Some of you might have seen that I left some zines outside, which Jason very kindly agreed to print, which I was really delighted about. And my goal with some of these zines is to try to explain like the basics of what you need to know in like 16 pages. Because I had this problem where I felt like I would like go give a talk at a conference and I'd be like, here's the stuff. And then someone would come up to me and be like, what was the thing you mentioned again? I'm like, no, I need a way to give it to you so that you can go read it on the bus and remember what I wanted you to know about TCP dump. So I started writing a few little zines. I started with strace because strace is my favorite program. And I wrote like a little zine, which is like, here's how you use strace to solve your problems. And I made one about computer networking. Because I was really confused about computer networking for so many years. And I made one about TCP/PDUM just recently, like last month. I have a few with me, / outside, because I didn't know like what command line options to use, and I thought TCP/PDUM was terrifying, but it's not. It's fine. It's not that big of a deal. And I have some of the things that I talked about in this talk in this zine called Linux Debugging Tools You'll Love, which there are a few hundred of outside. I hope that you learned something. I have a blog and I wrote some more zines there. That's all.